In this video, I am going to present what I consider to be very compelling proof for the flat Earth. I have total confidence in the data collected and the interpretation of the data, and yet I still don't really understand how this evidence could be so clearly supporting the conclusion that the Earth is flat. Because how could the Earth be flat? I can't even begin to wrap my head around that concept. But the evidence clearly supports this conclusion. I stumbled onto the flat Earth about 6 months ago, and I would say that since that time I've watched close to 200 flat Earth videos, maybe 1 or 2 per day, with a focus on videos that presented empirical evidence. And out of everything that I saw over the last 6 months, I never encountered anything that conclusively proved the flat Earth to me. I ran across a lot of videos that were very convincing, but nothing that ever sealed the deal and just convinced me 100% that this was true. There was always some little shred of doubt in each video, some aspect of the evidence that was ambiguous or subjective and could be called into question. So I started trying to develop some ideas for experiments or observations I could make to prove one way or the other conclusively whether the Earth was a globe or flat. I didn't really have an opinion on the subject, but I felt that the debate was interesting. I went through a lot of concepts and actually went out and did some experiments and didn't really find anything that I thought was going to deliver proof until I happened upon this test, which is actually quite a simple idea, but I believe delivers conclusive proof of the shape of the Earth. Part of the research for this test, once I came up with the idea, was that I had to find specific geologic features in a particular alignment with one another, and that took quite a bit of time. I spent a lot of time looking at maps on the internet and ordering maps off of Amazon and eBay and looking at those, just doing a lot of different types of research trying to find what I was looking for. As it turned out, what I was looking for happened to be in a place my wife and I hike in quite often, actually. It's a really amazing place to hike. We love going up there. It's called the Shining Rock Wilderness. It's located about an hour south of Asheville, North Carolina, on the Blue Ridge Parkway. And it's a really unique place. It's unique in that it has multiple peaks over 6,000 feet that are grassy balds, whereas most of the mountains in the southern United States are covered with trees. So you can hike up there and hike over these balds, and on a day with good visibility, you have a 360-degree view of about 60 to 70 miles in which you can see hundreds of mountain peaks. So once I had identified the appropriate geologic features and mapped out the approximate locations where I could conduct the observation, then my wife and I went up to the Shining Rock Wilderness, and it took us about 6 times altogether of doing much longer hikes than we normally do. We usually hike maybe an hour and a half or 2 hours a couple of times a week, and this required 5 and 6 hour hikes to get near the areas I had pinpointed on the map. So the way the process worked is we'd get into that general area, we would be on a trail, and we would kind of set up a mini base camp where my wife would wait for me, and I would descend off of the trail and make my way through the really dense brush of the mountainsides, trying to locate the precise point where I could complete the observation. We repeated this process until we finally found the right location to conduct the test. And we ran into a variety of issues while doing this. Sometimes the ridge I was on would descend too quickly and there would be a ridge in front of me that would be blocking my view, or the ridge wouldn't drop fast enough and my angle would be wrong and I wouldn't have the line of sight that I required. It was tough to get at the right elevation and also have a view of what I was trying to see. Then we also faced weather conditions. We'd have clouds move in, or it would get hazy towards the afternoon, and I would lose that 45 miles of visibility that I required to do the test. But eventually we did find the location to do the test, and what I saw when I got there was shocking to me. I mean, before I even set up the camera or anything, and I just looked out across towards the features I had identified on the map and saw them, as I expected I would, what they were showing me was that the curvature that should have been there, it just was not there. There was no way around it. The evidence I collected proves that the Earth is flat, which is ridiculous. But I welcome anyone to challenge this evidence and show me how it says anything other than the Earth is flat. Okay, so as to the design of the test, I'd like you to take a look at this beach ball, which is obviously spherical, as the Earth is claimed to be. So we're going to zoom in on a section of the beach ball, and imagine you have three objects affixed to the surface that are all the same height and in a row. So in this case I use toothpaste caps because we're all familiar with those. The regular line that connects the tops of those caps will also connect the bases and give you a very accurate representation of the shape of the object they're attached to, which in this case is the beach ball. So get rid of the line and the caps, and we're gonna zoom back out and get rid of the beach ball. In its place, we have the globe. Again, we're going to zoom in on a section of the globe, and same thing. Imagine you have three objects that are the same height, all in a row. In this case, I chose mountains because most mountains all over the world, the elevation has been recorded, and there's lots of sources for that. It's fairly easy to find three mountains in a row that are the same elevation. It took me some time, I think this, because it was the first time I ever did it. Trying to locate this was actually pretty difficult and time consuming, because you need three mountains of equal elevation, or actually you need two. One on either end can be higher, and you can actually just go down a little lower from the peak to make the elevation. But it requires certain characteristics. Those three mountains have to be in a straight line. Two of them have to be the same elevation. The third one has to be the same or a little bit higher. And the peaks also that you're observing have to be prominent. In other words, they have to raise up above the surrounding landscape. So mountains around those mountains. And they have to be prominent enough to where there aren't any mountains in between them that are taller. So they have to be tall mountains in a row without tall mountains in between them. So it's a little challenging to find this. It does take some research and maybe even going out and doing some observations and scouting around on trails, which is what I did. But it is doable. I think if someone wanted to repeat this at this point, with my help and some tips, it could be done fairly easily. And I would say that there are hundreds of instances of mountains of similar or the same elevation in a row all over the world. That being said, this is the same as the toothpaste caps. The regular line that connects the tops of those mountains will also connect the bases of those mountains and give you a very accurate representation of the shape of the object they are protruding from, which in this case is the Earth. Okay, get rid of the line and the mountains, and we're gonna zoom back out. Now we're gonna look at, instead of a sphere, we're gonna look at a flat surface. So in this case, it's a ruler. And again, imagine you have three objects that are all the same height attached to the surface. And again, we have the toothpaste caps, and again, the regular line that connects the tops of those caps also connects the bases of those caps and gives you a very accurate representation of the object they are attached to, which in this case is the ruler. And if we get rid of the caps and the ruler, instead we have a flat Earth, and 3 mountains that are all the same height, then we have the same phenomenon, that the line that connects the tops of the mountains also connects the bases of the mountains and gives us a very accurate representation of the object they're protruding from, which in this case is the Earth. Okay, so we're going to get rid of the line and the mountains and the flat Earth, and we're going to go back to the globe for a moment here, and if we zoom in once again on our section of the globe and we put our 3 mountains back, and for the sake of this demonstration we'll call this mountain number 1, and we'll call this mountain number 2, and we'll call this mountain number 3. So if you're standing on mountain number 1 and it's 5,400 feet and you're on a globe, and mountain number 2 is 5,400 feet and mountain number 3 is 5,400 feet, then if you're looking from mountain number 1 to mountain number 2, your line of sight is straight. But the surface that the mountains are protruding from, which is the surface of the Earth, is curved. So your line of sight is straight, but the surface of the Earth is curved, and so therefore you would never see mountain number 3, because the curvature introduces declination, visible declination of mountain 3, and it's going to drop down. Particularly if this distance right here between mountain number 2 and mountain number 3 is vast, 30, 40, 50 miles, then you're looking at many hundreds and even thousands of feet of declination, which is visible sinkage of the mountain. So it's literally sinking out of view from your horizontal line of sight over the top of the 2 mountains. Okay, that makes sense. So we're going to get rid of the line of sight and the mountains, and we're going to zoom out again and get rid of the globe, and let's go back to our flat Earth and our 3 mountains on the flat Earth. So if we call this mountain number 1, and this is mountain number 2, and this is mountain number 3, if you're standing on mountain number 1 and looking across to mountain number 2, then mountain number 3 should be either just barely visible or just barely obscured behind mountain number 2. And if you're somehow able to move perpendicular to the line created by the alignment of the 3 mountains, say 100 or 200 feet, and then look across to mountain number 2, and these peaks are all prominent, in other words, they're standing individually with nothing obscuring the side of them, then if you can move 100 or 200 feet off to one side, when you look across past mountain number 2, you would see mountain number 3. And of course that's on a flat Earth. So your line of sight would be right at mountain number 3. So that's the basic premise of the test. Find 3 mountains in a row, 2 of them of similar or identical height. One of them can be slightly higher, but put myself at the same exact elevation of the other 2 and look across and record the observation and see, is mountain number 3 visible, or is mountain number 3 not visible because the Earth is curved and it has visually declined by a significant distance? That's the test. Part of my quest in trying to put this test together was not only to find 3 mountains that were the same elevation in a row, but also 3 mountains that were well known and well photographed, so that anyone watching this video could validate for themselves that indeed I was actually recording the mountains that I claimed I was recording. So one of the mountains is Tennant Mountain, which isn't actually in the video, but is where the camera was placed to capture the shot. And actually I was on a ridge down in front of Tennant Mountain. And the foreground mountains, and in particular Frying Pan Mountain, is a really recognizable mountain. It's got a Forest Service tower on top of it and 2 communications antennas. Also included in the shot, but not really part of the test, is number 4 here, as you can see, Mount Pisgah. And Mount Pisgah also has a tower on the top of it, and it's a really popular spot for hikers, just like Frying Pan Mountain is. both of the mountains are very well photographed and well known, so it's going to be real easy for anyone to validate that the mountains I claim are in the video are the actual mountains in the video. As for the mountain in the background of the shot, Graybeard Mountain, there aren't quite as many pictures of it on the internet, but they can be found. And Graybeard Mountain is part of the Black Mountain Range, which rises up out of Black Mountain, North Carolina. There's really only maybe 9 or 10 prominent peaks on the entire Black Mountain Range. So with a little bit of work, it's fairly easy to confirm that the mountain I'm claiming is Graybeard Mountain is indeed Graybeard Mountain. Okay, and to do a little more validation here of my data, I have Google Maps. As you can see, there's Tennant Mountain listed. I was actually a little less than half a mile in front of Tennant Mountain. Not really at the peak, but down in front of it. And you can see that the distance from Tennant Mountain to Graybeard Mountain, not the trailhead, this is the only thing they list, is the trailhead. The mountain is actually right there, so it's a little bit further. They don't list the mountain for some reason, but you can see the distance is 40.43 miles, and I was about 0.43 miles in front of Tennant Mountain. So it's roughly 40 miles from my location with the camera to the peak of Graybeard Mountain. And then, of course, I'm looking past Frying Pan Mountain, which is somewhere in here, and I have a map for that as well. This is Frying Pan Mountain. See up here, Frying Pan Mountain to Graybeard Trail. Again, it's to the mountain. So this is Frying Pan Mountain. So Tennant Mountain was back here where the camera is, and from Tennant Mountain to Frying Pan Mountain is about 6 miles. Then you can see the distance from Frying Pan Mountain to Graybeard Mountain is 33.79 miles. And I just went with 34 miles. Okay, and with regard to locating images of the mountains that I used, you can see here, here's a search for Frying Pan Mountain. There are lots of images of the tower and from the tower. So there's not a ton of long-range shots of the tower like the one in my video, but they're out there. Here's one here. Mount Pisgah, on the other hand, there are tons of images of Mount Pisgah from a distance, where you can see the antenna and the whole mountain. That's easy to validate. There's another one. And Graybeard Mountain, it's kind of similar to Frying Pan Mountain in that people like to hike up to Graybeard and take photographs from it. So you don't see a lot of photographs of it so much. It's kind of like a bald, or mostly a bald. It used to be completely bald. It's got maybe waist-high shrubs on the summit now. And some of the images of Graybeard are from the wrong angle, so they don't look the same as the angle that I recorded. But I do have one really good source here. There's a website called masterviews.net, and a guy named Ken Gager who took a bunch of photographs of mountains from the overlooks all the way along the Blue Ridge Parkway, and he identified hundreds of mountain peaks in the distance. So this is a really good source. Actually, this image is very similar to the image that I collected. If we zoom in here, he actually shot this from Graveyard Fields, which is about a mile from where I was, maybe 3/4 of a mile. And you can see that the image, when you see what I'll show you a little bit later on, you'll see that it's very similar actually. He identifies Graybeard Mountain right here at 40 miles distance, which is the same distance I claim that it is from where I am. Of course, it's 3/4 of a mile from me, but I'm kind of lateral to his position, so I'm not closer to Graybeard, I'm just off to the side. And then there's Pinnacle, which is 42 miles away. And then these are most of the prominent peaks of the Black Mountain Range. So he's a good neutral source for photography of these mountains, because he has nothing to do with any sort of research of the shape of the Earth. And you can see here's Frying Pan Mountain. That means I'm off down behind this ridge here, which is Graveyard Ridge, off to the side. I'm looking past Frying Pan Mountain at Graybeard Mountain. you'll see that this looks very similar to the video I recorded, the evidence that I'll be sharing with you shortly. So that's some evidence for Graybeard Mountain. If you need to validate that what I'm showing you is Graybeard Mountain, then it definitely can be done. The Black Mountain Range is very identifiable. Like I said, there's probably only about 10 prominent peaks, and that would include all of the ones he lists here. So there's Graybeard, Pinnacle, Potato Knob, Clingman's Peak, Mount Gibbs, Mount Mitchell, which is a great place to hike, Mount Craig, which is another great place to hike. All of these are the most prominent peaks, I would say, of the Black Mountain Range, which rises up out of Black Mountain, North Carolina. Okay, so here's another graphic that I did, which is, it's actually 44 inches long. Every inch equals a mile, and I have all three of the mountains included in this image. So I have Tennant Mountain, where I was located out in front of, and then Frying Pan Mountain and Graybeard Mountain. So you can see that there's a large distance between Graybeard Mountain and Frying Pan, and then a much shorter distance between Tennant and Frying Pan. The green band along the bottom of the image is actually the surface of the Earth, and the curvature that I put in there, it's not really noticeable too much if you look at it, but it is actually accurate according to the mainstream curvature formula. So it's 44 miles, and there's 1,290 feet of declination from the left side of the image to the right side of the image. It curves down ever so slightly. It's not very noticeable, but it does. Now what we're going to do is zoom in on a section of this. Here's Tennant Mountain. The camera was located out in front of it and down below the peak, as it is taller than Graybeard Frying Pan. And I put myself at 5,400 feet with the camera. Actually, the altimeter, which I verified continually along the hike with topographic maps, was giving me a reading of 5,380 feet, which is really more my target height. I wanted to err on the low side. As you can see here, Frying Pan Mountain is 5,360 feet. It actually varies depending on where you go, from 5,340 to 5,360, maybe even 5,370. But it does have 40 to 50 foot trees on the summit, and I had to take those into account because it's a visual observation. So the mountain looks to be, let's say it's 5,350, and it has 40 foot tall trees, so it's 5,390 with the trees on the top. And I'll show you some images of those. So it was roughly the same as where I was. Like I said, I was at 5,380, and Frying Pan is maybe 5,390, 5,380. So close to being accurate that I just went ahead and went with it. And as you can see here, there's 6 miles of distance between Tennant Mountain and Frying Pan Mountain. Here's the curved surface of the Earth, which does curve downward throughout the entire image, whereas the horizontal plane line of sight is flat. You can see there's 6 miles between Tennant Mountain and Frying Pan Mountain, and then as we move along, the red horizontal plane stays level, and the surface of the Earth is curving down. It's declining. And the distance is 34 miles between Frying Pan Mountain and Graybeard Mountain. So in Graybeard Mountain, again, you get different elevation readings, anywhere from 5,370 to 5,410. I assumed it's about 5,390 roughly. And it has maybe 5 foot tall little shrubs on it. So it's going to appear to be 5,390, 5,395. It's going to be visually appear very, very close to the same elevation as Frying Pan Mountain. And then I've got a little bit of graphic in here. It just shows the declination we should have. You can see that, well, I'll just read this. The standard Earth curvature formula stipulates 770 feet of declination over 34 miles, and I will verify this shortly. This means Graybeard Mountain should visually sink to 4,630 feet. That would be 5,400 minus 770. It should not be visible from the camera position. Also notice that the scale is very accurate, as 7 times 770 equals 5,390, which is very close to the actual height of Graybeard Mountain. So in other words, the horizontal line of sight established from the camera position over the top of Frying Pan Mountain would be right here, and the 770 foot of decline is how far Graybeard Mountain should sink down out of view. So you shouldn't be able to see it looking across on a straight line. It should be down out of view by 770 feet, which is a substantial distance. And here are some of the elevation numbers for the mountains in the test. So I'm going to use summitpost.org, which shows Graybeard Mountain at 5408. I've seen it at 5375, 5385. I kind of figure it's right around 5400 feet, maybe 5395. And visually, it's not going to appear much taller than that because here's what the top looks like. So these are very low shrubs, maybe 3-4 feet tall. So you can walk around up on the top of Graybeard Mountain and you're just going to have a clear view, 360 degrees. So they add maybe 5 feet onto the top, visually speaking. So Frying Pan Mountain here on summitpost.org is 5340, and again I've seen it from 5320, maybe 5330, all the way up to 5370. So I take 5340 or 5350 as an average. And there are large trees. So this is the trail going up to the summit, and this is not far below the summit at all. The trail is actually quite short, and it looks like this the whole way up to the top and over all the way to the tower. And then here's a shot of the tower. You can see the trees all around it. I estimate those trees to probably be 40 feet tall. So if it's 5340 or 5350 and you have 40-foot tall trees, then you end up with, visually it's going to appear about the same as Graybeard Mountain and about the same as my camera position. And to verify the 770-foot number that I referenced, I'm going to use some mainstream sources for Earth curvature. This is DizHub, as you can see. It's a heavily used Earth curvature calculator by flat earthers and others as well. We're going to put in our numbers here. Our eye height is the height that we are above what we are observing. And that's going to be 0 because the test that I designed incorporates 3 equal heights. So that'll be 0. It would be the same as if your camera was exactly at sea level and you were recording straight out across the water. So your camera is level or 0 feet above what is being observed, which is the ocean in that case. And the same would be true for a camera at 10 feet above sea level. Imagine you're filming objects floating in the water that are 10 feet tall. Well, the camera would be 0 feet above the tops of the floating objects. So the eye height here would be 0. And our target distance is 34 miles. If I calculate that, we get 770 feet, which is exactly the amount of declination I said we would have. And here I have another Earth curvature calculator, just to verify this. I put in 34 miles as the distance, and the height of the observer above what is being viewed again is 0. And I calculate the hidden amount, which is the same as saying the declination, and it's 770 feet. So again, that matches the number that I provided. And then here we have one more website. I just wanted a few sources here to validate my number. This is someone who's not a flat earther. It's actually a math website. He's talking about the formula for the Earth's curvature. Here's what he says here, that flat earthers often claim that the curvature of the Earth's surface is 8 inches per mile squared. That's true enough over distances of several miles, and that the horizon should therefore have a noticeable curvature when viewed from low altitudes. He's basically saying that you wouldn't be able to see it. But he does use this formula, which is 8 inches per mile squared. If you go here, and I use that formula, so it's 8 inches times the mile squared, so 34 times 34 gives us the declination in inches, because we were calculating in inches there. And then if we divide by 12, we get the declination in feet. 770 feet again. I just wanted to confirm that my figure of 770 feet is an accepted mainstream number based on the accepted formula for the curvature of the surface of the Earth. Here's a topographic map of the area where we conducted the test. This is the Blue Ridge Parkway, and this is the turnoff to the Shining Rock Wilderness. Our main trail that we took in was the Ivester Gap Trail. What we were really trying to do was get around in front of Tennant Mountain. And I'll zoom in here. The reason for this is that Tennant Mountain is in a line with Frying Pan Mountain and Graybeard Mountain. But it's 6,040 feet tall, so it's too tall to conduct a test from the summit. The idea was to get around to the front and get down to 5,380 feet in order to do the test. So the first two attempts we made were off of the Ivester Gap Trail down this purple trail. You can see here the trail runs just under the 5,600 foot interval at about 5,500 feet. So I dropped down from the trail about 120 feet, and I went back and forth on this mountainside trying to get a view down this line of sight towards Frying Pan Mountain and Graybeard Mountain. The problem was, though, is that it was either this ridge or this ridge. I didn't know which at the time, or maybe even one further out front was getting in the way of the shot. We went up here twice in this area until eventually we just had to give up because I could not get a view. Then we decided to continue out on the Ivester Gap Trail. These purple trails denote our failed attempts, so this was our second failed attempt. The problem with this trail was that by the time we got to the line of sight, the trail had descended to about 5,300 feet, which was just too low for the test. As we were trekking around the mountainsides here, we came to realize that this ridge that didn't have a trail was most likely the one that was blocking my view, and also where I would get the shot. So we set up a little base camp approximately 20 feet below the trail. Here's our little base camp, you can see. And here's the altimeter, which verifies that we were at 5,670 feet, which is just about right. Because if you look at the topo map here, you've got 5,600 feet. 40 feet for each interval would be 5,640, 5,680. The trail's at about 5,690, and 5,670 would be just about right at 20 feet below the trail. Wisely, my wife decided not to go bushwhacking with me down the mountainside. That was a really good decision. It was extremely difficult. She waited for me here at the base camp, and I started just going down this ridge, trying to find a clearing. Initially I was trying to find a clearing, someplace I could set up a tripod that I'd been carrying with me. Eventually I came to realize that was never going to happen because the shrubs were never less than about 10 feet tall. This actually took me 3 separate tries. So I went down this trail that I made down the mountainside and made 3 different attempts to find the location to make the shot. And we actually came out here to this base camp and went through this whole process 3 different times. What I was doing was I was just moving back and forth on the hillside, just always looking for a clearing and trying to get that view until I finally realized I was never going to get a view on the ground and I had to start climbing trees. I would say I probably climbed about 15 trees altogether until finally on our 3rd trip I found the tree that was at the right elevation and on the line of sight. Luckily I had the tree saw, which you saw at our base camp, because what I realized was that if you climb up in a tree and it's at the right elevation and you have a good line of sight, you're sitting in the middle of the tree, the branches are all sticking out and blocking your view. But luckily I did find the right tree and I was able to cut away the branches and conduct the test, record the observation, and you will see that shortly. Here's another piece of data I'd like to share. This is a website called Peak Finder, which surprisingly I did not discover until about 3 weeks ago. This would have been really helpful in locating the mountains to do the test. I actually used to go up to Shining Rock Wilderness and look around at all of the distant mountains and wonder how I could identify them. I had actually even gone to a lot of different websites trying to find a way to identify mountain peaks. I'd gone to a site called Peakware and Peakery and probably several others, and just happened to miss this site. But anyway, this is going to be really valuable for us right now because This site is going to validate my claim as to which mountains we're looking at. So you can see here that this is the view from Tennant Mountain, which is correct because we're on a ridge slightly below the summit of Tennant Mountain. This is a really amazing technology in that you can virtually stand on top of most mountains in the world as long as they're recorded, and you can spin around 360 degrees. If you use this binocular tool here, you can actually click on almost all of the mountains around you, and you will get the elevation and the distance from you and the direction to that mountain. If we zoom all the way out here, you can see this is most likely the ridge we were on, and I was somewhere right about here. And this is probably the first ridge we were on in which my view was obscured. If we zoom in again, you can see that this is most likely the third attempt we made down this ridge, and this trail just dropped too quickly and our elevation ended up being too low. If you look here, you can see the mountains that will be in the shot and look very similar to this. So here's Frying Pan Mountain, here's Graybeard, the two primary subjects of the observation. Here's Pinnacle, which is also in the shot. Here's Mount Pisgah. Again, every website has slightly different elevations. So this website has 5,318 feet for Frying Pan Mountain, which is a lower elevation than I had claimed previously, but at the same time this website lists Graybeard as 5,364 feet. So that's only 46 feet of difference between the two. Okay, so that's it for the subject of the test. One other thing I did want to show you is if you look over here at this mountain, this is Little Pisgah Mountain. It's listed as 5285 on this website, and Frying Pan is listed as 5318. Most resources for elevations are going to show different elevations for Frying Pan Mountain and Little Mount Pisgah, but the difference is almost always going to be about 30 to 40 feet. So Little Mount Pisgah is always going to be listed as about 30 to 40 feet shorter. And if you look here, you can see that the distance to Frying Pan Mountain is listed as 6.6 miles, and the distance to Little Mount Pisgah is 9.2. If we turn off the binoculars, notice that if you draw a horizontal line across here, Little Mount Pisgah is up higher in the shot than Frying Pan Mountain, because the shot is from the top of Tennant Mountain, which is 6,040 feet. So when you look at the shot that I got, you will see that Little Mount Pisgah appears shorter than Frying Pan Mountain. So the shot actually validates my claim as to the elevation of the camera. Because if I were, say, 50 or 100 feet higher than I claim that I am, which I was at different times, then Little Mount Pisgah would appear taller than Frying Pan Mountain. And it clearly does not in this shot. It's very evident that Little Mount Pisgah, which is further away from the camera than Frying Pan Mountain and slightly lower, does very clearly appear slightly lower. The shot is actually validating my claim about the elevation of the camera. And we have Peak Finder, which is very clearly validating my claim about which mountains we're looking at. Here's a little model I made of Frying Pan Mountain and Little Mount Pisgah to illustrate the concept of the camera elevation really impacting what you see with regard to the perceived height of foreground and background mountains. So you see as the camera moves up, Little Mount Pisgah appears to be taller than Frying Pan Mountain, and if you keep the camera level with the top of Frying Pan Mountain, then Little Mount Pisgah is obscured, and it would appear lower off to the side as it is in this shot. So you can see the camera moves up and it becomes visible, the camera moves down to level with Frying Pan and it's no longer visible. Even here when it's off to the side, it's clearly lower than Frying Pan Mountain, which is exactly as it appears in the video. The distance from camera to Frying Pan Mountain is just about 6 miles, and Frying Pan to Little Mount Pisgah is 3 miles, which is half. So if I were to raise the camera up 100 feet, it would cause Little Mount Pisgah to visually raise up half of that 100 feet, which would be 50 feet. Seeing as how it's only 30 feet lower than Frying Pan Mountain, it would appear to be taller. And it does not appear to be taller in the shot. It clearly appears to be lower, just exactly as it is. The same would apply if I were to, say, have the camera 60 feet higher than what I'm claiming. Then again, at that point, because Little Mount Pisgah is about 30 feet shorter than Frying Pan, it's going to appear to be level with Frying Pan, and in the shot, it appears clearly to be lower than Frying Pan Mountain. So I would say that the elevation that is being shown by the altimeter is accurate to within 10 feet. I feel very confident about that. Not only because of what I'm showing you here, but because I actually validated the accuracy of the altimeter many times. I did that at the Blue Ridge Parkway overlooks and all along the trails, checking it against the topo maps, and it was always very accurate. Once I was able to locate the right tree and get up into it, I had a little bit of preparation to do. So the first thing I had to do was cut away the branches that were obstructing my view. I also brought a cordless drill and some pieces of wood and screws with me, and I built this little camera platform to stabilize the shot, because on previous attempts in other trees, the shot was extremely shaky. Actually, the wind was blowing stronger on those other days. Luckily, on this day, the wind was milder. With the platform and less wind, the shot ended up being fairly stable. Here is the actual shot, and this is the shot, the one that I was trying to get the whole time. You can see here that the altimeter reads 5382. What we're going to do real quick is take a look at Frying Pan Mountain and Little Mount Pisgah before we continue with the shot. We'll go ahead and freeze it here, and you can see that Frying Pan Mountain, as I claimed previously, does appear taller than Little Mount Pisgah. We're going to zoom in on this, and you can see here that this horizontal line, Frying Pan Mountain, looks a little bit closer to it than Little Mount Pisgah. Now, of course, there are things that could cause this to look this way, and my claim could be incorrect. I could be out of level by 1 or 2 degrees. It's possible. And the elevations for all of these mountains, the more sites I go to look at elevations, the more numbers I get for these mountains. But they're always within 30 or 40 feet. Usually 30 feet, and occasionally they're off by 50 feet. So the elevations could be slightly different than what I'm reporting, but we're close. Everything's very close. And the elevation of the camera and the accuracy of the altimeter could be called into question. Maybe I wasn't at the exact elevation I say I was, but again, I know I was close. I have a great deal of confidence that I was within 10 feet of where I claim I was. But anyway, this right here, this shot does actually suggest that I was at that elevation. Little Mount Pisgah being 9 miles away and Frying Pan being 6 miles away, if I was, say, 100 feet higher than what I claimed, then Little Mount Pisgah would appear higher, and it doesn't. At the very least, they're level, which clearly implies that I'm very close to the elevation that I claim I'm at. And as I said, there's not enough of a difference possible, or enough of an inaccuracy possible, in either the elevation of the camera, the elevations of the mountains, or how level the camera is, to account for the actual shot of Frying Pan Mountain compared to Graybeard Mountain, because it just does not make any sense. None of the explanations or reasons or justifications that I could come up with to explain it away actually do explain it away. I'm going to zoom back out, and we will continue with this shot shortly. So I'm just going to let this shot run for a while. I captured a lot of this video, and none of it is great. My camera's fairly good. The stability of the little platform I made was okay. The tree was moving around a little bit. I was moving around a little bit. But it's clear. You can see what I intended to have you see. There's Frying Pan. To the left is Graybeard. To the left of that is Pinnacle. To the left of that is Bald Knob. And Graybeard and Bald Knob are basically about 5,400 feet in elevation, which is about the same as Frying Pan Mountain. But they're 34 miles back. Actually, I think Bald Knob is 36 miles back. In this shot, you just see no... There's the altimeter again. And one note on the altimeter is that, I checked it when I got back to base camp every single time. It was accurate. I checked it when I got back on the trail every time. It was accurate. So I don't have any reason to believe that it's inaccurate. I'm just trying to play devil's advocate here and look for what could possibly be wrong with this observation. This observation shows these mountains on a flat plain. Now, I don't know why that is. I mean, I can evaluate evidence and tell you that that's what the evidence says, and I don't see any evidence for refraction. Every single time I went up there trying to capture this evidence, the mountains were at the exact same position. They didn't raise up and lower down. Refraction wasn't moving them around. There was no, unless it was consistently moving them up or down the same way every single time. And every single day since that I've been up at Shining Rock, and I've probably gone there 12 or 15 times since, and I'm always looking over at those mountains. I have like a little line of sight that I can use to check, and the mountains are always exactly the same height. They don't move around. If refraction is occurring, it's the same refraction every single time, consistently, without fail. This shot I find to be completely bizarre. Do I believe that the Earth is flat? That's a big leap to make. A really big leap to actually believe in a conspiracy theory of that size. It is craziness. But what am I supposed to do with this evidence? I don't really know. Honestly, I don't really know. But I felt compelled to make this video. I felt compelled to collect irrefutable evidence one way or the other, so I could end the internal debate I was having about it and answer the questions I was having regarding flat Earth, because I did find the debate interesting. What we're going to do is we're going to freeze the shot right here, and this is the shot that I was attempting to capture the whole entire time. And this is Frying Pan Mountain, as you already know. This is Graybeard. This is Pinnacle, which, as you can see, is roughly 250, 255 feet taller than Graybeard Mountain, and that's kind of the average of all the different sources. And then there's Bald Knob, which I haven't mentioned before, but we'll just take a quick look back at Peak Finder to confirm that Bald Knob is the peak we're looking at. So here's Frying Pan, here's Graybeard, and then here's Pinnacle, and here is Bald Knob. They show, I think, on this site, Bald Knob is, 15 feet higher than Graybeard. But again, I went with the averages of a lot of the other sites that I was looking at, topographic sites, and some of the other peak locating sites. Again, it's kind of irrelevant, because if I were to change the elevations 30 or 40 or 50 feet here and there, we still essentially get the same result of the observation. If Graybeard is 5395, Bald Knob is 5375, that again is an average. Graybeard is 34 miles from Frying Pan Mountain. Bald Knob is 36 miles from Frying Pan Mountain. If we put a horizontal line in here, you can see that the line barely touches Graybeard, and it's slightly above Bald Knob. Now maybe that's 100 feet or more, so that might not be, I might be slightly out of level, like I had mentioned previously. So what I wanted to do is show you that if I tilt the image and get Graybeard and Bald Knob to both touch the line, or just barely miss it here on Bald Knob, which would be really accurate, it really makes no difference. The line is hitting about the same place on Frying Pan Mountain. So what I'm going to do is just leave it the same. Furthermore, the other thing is that Bald Knob is actually 36 miles away, whereas Graybeard is 34 miles away. If I were to go to the Earth Curvature Calculator, you can see here that 36 miles away gives 864 feet of declination, whereas 34, as we already know, gives 770. 770 versus 864, well, that is 94 feet of extra declination. What that means is that bald knob on a curved Earth should actually appear a little bit lower, but as I said, I can tilt it either way, and it just doesn't make enough of a difference. So I would say we're within the margin of error everywhere here. So what I want to do is, first of all, point out the fact that Graybeard Mountain should be down 770 feet. Down this way, somewhere around in here. And it should appear lower than Frying Pan Mountain. And the fact that Bald Knob and Graybeard are essentially the same elevation, you can draw a horizontal line across them. And you're going to get a really accurate result. You're going to know that what you think you're looking at is what you're looking at. The camera's not tilted radically, giving the illusion of Frying Pan Mountain being lower. Frying Pan Mountain is lower, clearly, and it should be higher, visually speaking. Okay, so we're going to get rid of the horizontal line and Frying Pan Mountain and Graybeard. And we're going to leave Pinnacle and Bald Knob because they are roughly the same distance from the camera position, and the average difference in elevation between the two is 260 feet, which looks like this. So that is 260 feet. And again, that is an average of the resources that I used for elevations. Some sites listed the difference at 280 feet. Other sites listed it as little as 240. I chose 260 as a nice median number. And again, I could change that number by 10 or 15 feet, and it's not going to have any sort of real impact on the final rendering. The outcome will basically be about the same. So 260 feet times 3 looks like this. So 1, 2, 3 is 780 feet, which is the approximate declination which should occur and is not present in this observation. So the declination we should be witnessing should be from here to there. So, in other words, let's get rid of all this now, and get rid of Pinnacle and Bald Knob, and we'll put Graybeard back. So what we're going to do is we're going to take our scale reference for the declination that we should be observing and move it over to Graybeard Mountain. And then we're going to get rid of all of the lines but the bottom line, and this is roughly where the top of Graybeard Mountain should be. So, this is our outline of our mountains. Then our mountains should actually be roughly down about here, not up here. So if we go by the mainstream accepted and taught curvature formula for the spherical surface of the Earth, then Graybeard Mountain should not even be visible. We shouldn't be able to see it. So, and maybe, as I've mentioned multiple times, the elevations are slightly off by 20, 30, 40 feet. And so maybe Graybeard should be right there. Or maybe I'm out of level with the camera, and Graybeard should be right here. But there's no possible way Graybeard should be right here. It should be there, roughly speaking. We should not be able to see it. So this is the conundrum, the paradox, the thing that I have tried to figure out ever since I collected this data. Why is Graybeard up here when it should be down here? Why is this entire mountain range up much higher than it should be? Frying Pan Mountain, Graybeard Mountain, and Bald Knob are all roughly the same elevation. But Graybeard Mountain and Bald Knob are 34 and 36 miles behind Frying Pan Mountain. So they should be massively declined out of view. And they're not. They actually look as though they're on a perfect level with Frying Pan Mountain, which is only possible if the surface they are protruding from is level, unless somebody else can offer me some other explanation. So that's my video, and that's the evidence I present. I welcome anyone to explain this to me in a way that makes sense as to why these mountains appear essentially level with one another, and explain to me why there is zero curvature recorded in this observation. The only explanation I can come up with is that the surface they're protruding from is flat and not curved. But if there is another explanation and someone could offer it to me and it makes sense, I am perfectly willing to accept it. So thank you for watching my video. You can leave comments or write me an email if you'd like, and I will definitely get back to you. As I said, anyone who can explain this to me in a rational, logical way, I would greatly appreciate it, because I have spent many hours trying to explain this to myself, trying to find a reason other than the Earth is flat for this observation, and I've yet to find it. Thank you.